So up to now, we've been considering you using the Git repository as a single user working in isolation. However, things get much more interesting when you've got multiple users working on the same project. And let's discuss that a little bit and the things you need to be aware of and things that can be tricky at points. So basically, in that situation, you work with remote repositories and then you make a clone. We already did that. So basically, it's a local copy of the entire repository, and that's made in a local directory, which can live on your laptop, which can live on a VSC cluster, wherever. So creating a clone from a remote repository is fairly easy. You use a Git URL and you use SSH in order to ensure that your communication is encrypted and is safe. Git clone and the URL. You can also create a clone of a remote repository using HTTPS, so that is also sort of encrypted, but the problem is you always have to provide your username and password, which is not so very convenient, or you have to store that, and that's not so very safe. So basically using SSH is obviously the better option. Okay, so let's revise the work cycle in the context of multiple users. So the first thing to do is to update the local repository to the remote repository version. So you do a git pull, the origin, that's the remote, and then the branch which you're dealing with is typically master. We'll come back to branches later. And then of course we go into the usual cycle of creating files, editing files, adding directories, staging for commit, etc., etc. But before actually doing the commit, it's always a very good idea to do another git pull just prior to your commit, because it might be that something has changed in the remote repository and you want to know about that, because otherwise you might create conflicts, and although that's not a very big deal, it can be annoying. So it's better just to pull first and to see whether there are any problems or not. Okay, if necessary, you resolve the conflicts. We'll talk about that later, and then you can safely commit into your local repository. And when that's done, you can push to the origin. So basically, that's your work cycle. Git pull, do stuff, try a pull again, commit, and push when you're done. Okay, so how can you get conflicts? Well, two people are working on the same project and they're pulled, so basically the second has a copy of the repository, a local copy, and person A does the same thing. Okay, now person A is working on it, and she pushes her changes to the remote repository, which is perfectly fine. Meanwhile, the person B is also doing changes, and those changes might in fact conflict with ones which were already done by person A. So basically, if B tries to push the project, the push will fail. And that's because the working copy is out of date. So no problem, you just have to pull first, resolve conflicts if any, and then you can push. So basically, you merge due to pull, and that can result in a conflict. And basically, the auto merge fails. You get a conflict on a particular file. So there is a conflict in eq.c. Okay, don't panic. It may be a bit scary when you start using Git, but actually it's not that big of a problem. So it's simply resolved by editing files. So basically your file will now actually look like this. So there will be these markers, which you see the head and the master marker. So the head is your local repository. That is the current branch, and the other is the branch being merged in. And as you can see, there is indeed a conflict. I ranges from 0 on head, and I ranges from 1 on master. And likely one of them is actually wrong. And if you look at the code, the last line, then you see which is the correct one. So how do you resolve this? You simply edit that file. And basically you edit it into a state which is okay for you. And indeed, it is the I equal to 1 assignment that is the correct one. So you edit it until you're happy with it, and then you resolve all other conflicts, you stage, you pull, and finally you commit and you're done. So there's nothing more to it than that. Just editing a file, bringing it into a state which has no conflicts, bring it into a state which is correct. So basically conflict resolution always happens on a local repository. And when you're done, you push and the remote is updated. When you mess up, well, everything is in your local repository, so basically you still have the remote. It's very important that you familiarize yourself with the merge process, because it seems intimidating at first, but it's not so very difficult. However, if you're under stress for a deadline or something like that, that is not really the time to learn about merging and resolving conflicts. So basically, just practice. Just create a conflict artificially and just practice, because it will pay off. So for instance, it may even pay off in a single user scenario, and I'll show you later on. Basically, you work on multiple computers and you forget to pull on one. You work on multiple branches and you forgot to merge. So there are quite a number of scenarios in which you get conflicts even in a single user scenario. So one thing which is nice is that Git is pretty smart about merging. So that's a good thing. It's much smarter than Subversion about it, for instance. So let's talk a little bit about branches, because I have been mentioning them, but we didn't really go into any details yet. So when you're working in a team, you do task delegation, adding a certain feature, fixing certain bugs, or whatever. And basically the workflow which you can use for that is something like this. You have the master, and the subindex indicates the commit in a symbolic way. And you create a feature branch X from the master. So that is of course a new commit, but in a different branch. And then you edit your project, you edit your files, you get new commits and so on. And someone else can actually create another branch, in this case Y, from master, and again that will be another commit. And also the person working on Y makes changes, makes commits, and so on. Okay, so when Y is done, he merges his changes back into master. So basically master is now up to date with the work which was done in the Y branch. And in fact, that Y branch can then cease to exist, it can be removed. Meanwhile, the person who is working on branch X is continuing his work, and at the end of the day, he will also merge that into master. And this, of course, is where potentially conflicts may arise. So before merging X7 into the master, it would be a very good idea to pull the master and merge the changes which were made to master meanwhile, so basically whatever happened in the Y branch, into the X branch, if necessary resolve conflicts, and then merge X into the master. So basically it is also very convenient in a single user scenario, and typically this is my typical workflow. So I will have feature branches for things that I add, because I can work on several things in parallel without getting stuck with things that depend on one another. So a branch lifecycle is you create a new branch, you check it out to switch to the new branch, usually add commit cycle until you're done. When you're done, you switch to the original branch and you merge the new branch into the original. and you delete the new branch. So basically, that's your typical work cycle. So branches are short-lived and they're single purpose. One thing which you see very often with, let's say, people who start out using Git is, yes, they create a feature branch, but its scope is too large. So they try to accomplish too many things within a single branch. And that means that the branch is not short-lived, that it may exist for months, and then keeping it up to date with whatever else happened in the repository, and hence minimizing conflicts, is more and more difficult. So branches should really be short-lived, and they should have a very limited scope. They should be really single purpose. It's something that, again, you learn with experience over time, so don't worry too much about it when you start out. You will notice when you're not really on the right track, and next time you will do better. So let's make this a bit more concrete. Creating a branch is just with the git branch command, and you just mention the name of the branch which you want, and there is a convention there. You see feature/gradient descent. So this tells us that this is a feature branch, which means it's a feature I want to add to the software, and the name of that, the description of that, is gradient descent. So I want to implement some gradient descent feature or algorithm for whatever this software is for. And then you switch to the new branch. You do a git checkout, again the name of the branch. So git checkout just brings you from one branch to another. If you wanted to switch back to the master, you would do git checkout master. So that's the way to go from one branch to another. Then you do some editing, committing, etc., etc. And then I already mentioned that. So basically choose branch names descriptively. So feature and then a description, or bug fix and a description, and so on. Also make that consistent. So basically, if you work in a team, make sure that everyone knows about this convention. It simplifies your life considerably. Okay, so merge the branch back in. So you go back to master, and then you git merge feature gradient descent. So all the changes that happened in the feature gradient descent branch will now be merged into the master branch. There may be conflicts, so you would have to resolve them and commit them, and then finally merge. And then you can delete the merged branch, git branch -d, a feature gradient descent. So if you were a bit unsure whether you should merge or not, then you can actually do a merge without a commit. So that would be git merge -- no commit, -- no feature fast forward, feature gradient descent, and then it will report on either success or potential problems. So if it's okay, then you can decide to commit. So you just do git commit with a commit message. If not okay, then you resolve conflicts, or you can even reset completely by git reset -- hard original head. Okay. So if you have local changes when you're switching branches and they have not been committed yet, then Git will complain. In general, that's a very general design feature of Git. If Git suspects that you could lose information, then it will not allow you to do that without confirmation. So one of the things which you might do is you might be working in a branch and you're, for whatever reason, not really ready yet to commit that. Okay, but you want to switch to another branch. And in that other branch, of course, certain changes are not present yet. So that would mean that if you do a checkout of that other branch, it would potentially override changes you made and did not commit yet. So in that case, you can actually stash things away before you check out another branch. And that can be very convenient. The downside of that is that there is typically no visual reminder that you stashed stuff away. And it actually happened to me that I made some changes. I stashed them. I switched back to the branch, came back like a month later to that that branch where I had stashed stuff, and was very surprised that I couldn't find some changes which I made and which I was really sure of that I did. Okay, so basically I re-implemented them, and only later I realized that in fact I just stashed them away and I should have unstashed them so to get them back. So stashing is nice, it's a very good feature, but you may shoot yourself royally in the foot with it as well. Okay, so branching policies. Typically your repository has a master branch, or nowadays on GitHub, a main branch. So that should be stable. It can be used by others, of course at their own peril, but basically it's supposed to work, it's supposed to compile, it is supposed to typeset if it's a Lake document, whatever. Basically it's something that is stable and usable. And then you can have other branches, and the typical branch is development. So that is not stable, but that is the basis for new development. And it may differ from the master branch. So it's sort of stable, but only for internal development. And then you have one or more feature branches. And these you typically derive from the development branch. So not from the master branch, but from the development branch. And those, of course, are typically unstable and potentially buggy, since it's new work. You're just adding features, you're fixing bugs and so on. So obviously that code is not perfect. But you know that because it's a feature branch. So by convention, you know that unless you really know what you're doing, you should not use someone else's feature branch. Okay, and then basically when that feature is implemented, you merge it back into development. Then of course development is supposed to be stable again. And then when enough features have been added, or when you think, well, okay, it's time for a release, then you merge the development branch back into the master branch. And then the master branch has all the most recent features. And of course you can have multiple branches and so on. And then of course you use tags in order to, for instance, denote certain releases or certain events in your research project. And of course, these releases in terms of software are supposed to be stable and ready for production. So feature and bug fix branches are short-lived. Again, I'm stressing this because it is quite important that you get the hang of that. Okay, so normally when you clone a repository, you don't get all the branches. You typically get the master. If you want others, you can just do a git fetch and it will fetch other branches. You can also fetch specific branches, that's no problem. You can list all the remote branches by doing git branch -r, and then you can fetch a specific one from origin. Development is the name of the branch at origin, and after the column there is the local name. You can choose those to be different. Of course, if you want to make your life difficult, then choose them differently and you will get confused and you will shoot yourself in the foot. So typically you would use the same name for the remote branch and for the local branch. Okay, it's also possible to track remote branches, so then you just do a -u, and that can be very convenient. Okay, it's also possible to create branches directly from revisions or from tags, and that is very convenient, because suppose that you have let's say a version 1.5 of your software out, but also a 2.0. However, many people are still using 1.5 and a bug is discovered. So basically it would be a good idea to fix that. And then of course you need a branch, a bug fix branch, which is based on the 1.5 tag, for instance. So that's possible, and that's very easy to do. So git branch, and then you specify the branch name and the commit on which you want to base that, or the tag on which you want to base that. Okay, so history of merges. A branch obviously has multiple commits, and upon merge, history is merged. So basically you would have git clone, and if you then do a git log with a one-liner and a graph, you see something like this. So basically the vertical line indicates the master branch, and you see that at commit A0 DC there is a branch, and there are 4 commits, and then the last commit 889D, that is a merge commit. So this may be confusing. This is a problem but it's typically not confusing if you have a simple project. If you have a project with many people working on it, then this can become quite a challenge to see what's going on and to understand what's going on. So this would be the feature branch, and that would be the master branch. So basically we have 2 changes to the master branch, 2 commits to the master branch, and 2 commits to the feature branch. So it's also possible to squash commits, because basically once you have a feature branch, you have potentially many commits in that, but do they matter? Opinions on that differ, but some people say, well, okay, once the feature is implemented, then you don't really care anymore about the history of that particular feature branch, and you want to make that into a single commit message, and that's possible. That is possible by squashing. So here in this particular case we have a number of commits, a few to the feature branch and a few to the master branch. So basically there are 3 relevant commits here, and you can rebase, and as you can see we do a head till the 3, so the 3 latest commits, those will be squashed into 1 commit, merged into 1 commit, and that is the -i ensures that that is interactive, so you get an editor and you get something like this. So basically there are 3 commits, and you see the commit ID, and you see the commit subject, and this is something you can edit. So basically you can either pick a commit or you can squash it, and basically what we want is we want to squash those 2 commits into 1 commit with the pick. And basically you do that by editing the file and replacing pick by squash for the 2 commits you want to squash away. Okay, once that's done, you can edit the commit message, and basically you can make that a bit more sane, and you can then actually merge or cherry pick or whatever. So it happens frequently that you want to see the differences between branches, and Git makes that quite easy. For instance, if you want to see all the differences between your current branch and, for instance, master, you just use git diff master. However, this typically gives quite a lot of output. You will see the diff for each file that was modified, and that can be somewhat overwhelming and actually be more information than you're interested in. Very often you just want to see only the file names of those files that have been changed, and then you can just use the -- name only optional argument to git diff to get a more concise output. You can also compare a specific file. In that case you would use git diff and then -- the name of the file you want to compare and the other file. So basically you indicate the branch in which it resides, so in this case master, and again the file name separated by a colon.